If I multiply 1 centimeter by 1 centimeter, that's a centimeter squared. If I then multiply that by another centimeter deep, I get 1 centimeter cubed. What would be the abbreviation for a centimeter cubed? What would be the abbreviation for a centimeter cubed? CC. And you've heard this in medical TV shows. Give me 35 cc's of sodium penthanol stat. Like when they're saying cc at the doctor's office, they're saying cubic centimeter. And the cubic centimeter is a nice metric thing where 15 cubic centimeters is the same thing as 15 milliliters. 1 centimeter cubed is the basis of the metric unit of volume, the liter. It is 1 milliliter is a centimeter cubed. All right. And so medicine, which wants to be precise, they don't want to have to be like, oh, we give them 16 fluid ounces, divide that by 32. Like, they don't want to be doing this. They want it to all be nice, even base 10, good math that they can do. And so they use metric stuff. 20 cc's is 20 milliliters. 25 cc's is 25 milliliters. It's a nice one-to-one, easy conversion. For reference, 10 drops is about 1 milliliter. What is bigger, a teaspoon or a tablespoon? How many times bigger is a tablespoon than a teaspoon? We don't know because we live in this crazy system. Like we don't know these things. A teaspoon is actually not about, but it's exactly 5 milliliters, and a tablespoon is 15 milliliters. And as soon as you know their metric equivalents, you now know the relationship between those. How many teaspoons make up a tablespoon? 3. And so if you're doing some holiday baking and it calls for a teaspoon and you only have a tablespoon, just do it 3 times, and that's like the same thing. A teaspoon is a third of a tablespoon. Easy like conversions to know when you know their metric equivalents. Smile and nod. This is volume. What else do we have to keep track of in chemistry class? Weight. How are we going to turn these volumes into weight? Pounds, no, my friend, not pounds. Okay? They wanted, once again, the French Enlightenment guys who wanted to have a good system, wanted the gram. They said, what are we going to come up with that anybody can find? We're going to take this 1 centimeter cubed, and we're going to fill that milliliter with something that we know any future civilization should have access to. What is that? Water. They said if we take 1 centimeter cubed of water, that's going to equal 1 gram. And I'm actually going to change this. I'm going to make this 1 milliliter of water. 1 milliliter of water is defined as 1 gram. That's where the gram came from. Okay, is 1 milliliter of water. If I have 1,000 grams, how much weight do I have? A kilogram. If I have 1,000 milliliters of water, how much water do I have? A liter. How much, therefore, does 1 liter of water weigh? A kilogram. A Nalgene bottle, a normal like hydro flask size thing of water, a liter of water, that's a kilogram. Okay? That's how much a kilogram is, just like a physical sense of what that's going to be. This makes our math really easy. Oops, I'm 1 slide off here. What is the weight of a 2-liter bottle in metric? 2 kilograms. Okay, 2 liters equals 2 kilograms. If you've ever held a 2-liter bottle of soda, that's 2 kilograms. Do you know how much that weighs in pounds? I bet you don't, but you already can know it automatically in metric because it's a good system. Right? How much would this 350 milliliter soda can weigh? 350 grams. Right? Because 1 gram, or 1 milliliter weighs 1 gram, 350 milliliters is going to be 350 grams equals 1 can of soda. Write that number down in your notes. 350 grams equals 1 can of soda. Why? Because it's kind of good to know and I'm like, go get 10 grams that you should then know is not a whole lot. Okay? So I'm saying 10 grams, that's 1/35 of the weight of a soda can. Okay? One easy thing to say is how much does one paperclip weigh, approximately? Oops. Indeed, one paperclip weighs 1 gram. Just as a handy reference, one paperclip, 1 gram. Sing. And now a quick science lesson on some scientific equipment. We have 2 things here, thing A and thing B. Which one of those is a beaker? Let's have applause for A. Let's have applause for B. Correct. In your notes, draw a little cup-shaped thing and label that as a beaker. And then draw one of these things. And it can be as ugly and asymmetrical as my drawing is. And label that an Erlenmeyer flask. What is the benefit of an Erlenmeyer flask unlike a beaker? What is better about an Erlenmeyer flask?
Easy to pour stuff out.
No.
Shoot.
No. You can what? True, that's not the main advantage. What is the benefit of this shaped device as versus a normal cup? Why did scientists invent this thing? How is it safer? You're right. When you tip it over, it doesn't pour out as fast. If you have a full cup and you knock it over, your stuff is on the table immediately. If you knock it over something that has a slightly narrower thing, it takes longer to get out. Also, it's less likely to take and pass around, just hold it for a second. It's less likely to fall over because it's wider at the base. It's more stable. So it's less likely to fall over, and when it falls over, it doesn't all rush out as fast. Now that you're holding one in your hand, guess how many grams that thing is. Just for approximate sense, guess how many grams. I'm going to give some candy to the person who can guess this the closest. We're passing around. Tracy's got to guess even though he hasn't touched it yet. Go ahead, sir.
3 grams.
He's guessing that's the same as 3 paper clips. Let's have another guess. 200 grams. That is your exact guess as well? Yo. Carlos.
400.
He's going big. He's saying 400 grams. 140. Just cutting Ava off at the pass there. All right. Let's pause. Write it down on a piece of paper right now. Write it down. If you think you got a better guess, write it down.
Can it be the same?
He's revising his guess here. Okay. We're going to see who gets a piece of candy. So. Okay, you got your number written down. You got your number written down, ready? Here we go. The truth here is 93.
I said 75.
If you got it,
said 70.
you see it written down? What do you got? You see it written down?
99.
Okay. There you go. You written 92 if you get it. Alright, so that is not the point of this. That gives you maybe a little ballpark figure, okay, to know that that's like 90-ish grams. Okay?
Tell him that.
Well, Daddy, give it to him. All right. Okay. All right, whatever. It's like 90 grams-ish. Okay? Now, the more important and easier thing that we're going to do next is play the game. How much would it weigh, my focused chemistry students, if we had 100 milliliters of water? Write down a number on your piece of paper. How much is it going to weigh if I put 100 milliliters of water into that empty Erlenmeyer flask? How much is it going to weigh if I put 100 milliliters of water in there? Let's say it all at once here. 1, 2, 3. 190. This one says 191 right now, but the point is that it was easy to guess. Okay? It was easy to get a good ballpark figure that if you have 100 milliliters, that's 100 grams, plus 93 grams is going to be around 100 grams, 190 grams. We got 191. I may not have measured my volume precisely. Smile and nod, easy to do. All right. Let's talk about this problem. What is heavier, a kilogram of steel or a kilogram of feathers? Same. But regularly, people get this wrong on like national TV show game shows, right? Where they're like, boy, this sure seems big. Right? That must be heavier. Right? This is bigger in terms of what category that we've just talked about. Volume.
Exactly.
Okay? This has a big volume. These are the same. Liam, you were just answering the wrong question. Liam, these are the same in terms of course. He was thinking ahead. He was thinking ahead. Same mass, different volume. This is something that eludes people to some degree. Okay? Volume is how much space something occupies. Write this down. Volume is the amount of space that something occupies. What is mass that is different from this? Good. She's got most of the words there. Amount, gravity, and force are all in this sentence. Okay? Mass is like the force exerted by gravity on an object. If you want to be persnickety about it, this is technically weight that we have written on the board here. And if you were to do chemistry on Mars, mass and weight would be different things. We will not do that. Maybe when you go over to the dark side of the hall, if you survive long enough to do physics, don't Joel, and you survive, you should be able to, there they will talk about differences between mass and weight. Okay? Over here, mass and weight will be the same thing. I don't want you to be going technically, that's weight. It's the same thing for everything that we're going to do here. People in our society obsess about which one of these most? Weight. Amazingly, people will say that they're worried about their weight over the holidays. Here's an example of 2 Olympic athletes that probably outweigh me. In fact, they do outweigh me, that are still in great shape. But people assume that if they weigh 190-something pounds, that they are not in good shape because people conflate these two things. People assume that what they need to watch over the holidays is their weight, when in fact, what is the thing that you need to pay more attention to? Not mass. Right. But we don't have home volume measurement devices. Nobody has some tub that they can get in to see how much water they're displacing today. That's actually what you probably should be obsessing about, because we don't have the ability to obsess about that. We obsess about this other criteria. You can be in really good shape and have a high weight, but people just assume that is, because that's the only device they have for measuring in their house, that's the thing they should be obsessing with. Of course, we should not be obsessed with any of these things, but if you're using the term I really need to watch my volume would be the appropriate thing. Going to this holiday party, I got to watch my volume. I'm going to say no to that third dessert. I had 5 slices of pie Thanksgiving. Okay.
Apple.
No, wait, pumpkin, all the way, pumpkin, apple. You guys are crazy. Pumpkin. Okay. Pecan too. I like pecan. All right. Chemistry and metric prefixes you should know. You probably already know most of these, but we're just going to make sure we have these last bits. Okay? Kilo. When do we use the metric prefix kilo? Kilograms is 1. And we don't talk about kiloliters very often. We do talk about kilometers. And a kilometer is actually a kilometer, mispronounced because it's become such a common word. So a kilometer is 1,000 meters. Right? We will not use deciliters or meters very often, but we will talk about decimals. Okay, and decimals is like 1/10 dozen. So what decimal does that go to? That scale right there, if Cole looks at it, it goes how many decimal places, how many places past the decimal point does that go? 2. So that is measuring the what? Centigram. That is measuring the centigram. Joe, you'll notice how like this idea of whether it's weight or like what word, like to us who've done science, like this is obviously that's measuring in grams, but that's what part of what we're teaching today. Weights are in grams, volumes are in liters, and distances are in meters. I'm going to say that just for a pause second here. Okay, weight or mass is based in the gram. Volume, how much space it takes up, is based in the liter. And distance is based in the meter. But again, we will use derived units of almost all of these. We will actually talk about grams more than like kilograms. You're never going to get like a kilogram of chemical. For the liter, we'll be dealing with the milliliter. For the meter, we'll be dealing with the centimeter. Okay, getting back to the prefixes in 5, 4, 3, 2, 1. So that scale reads in centigrams, but like I just wrote, centimeters is a unit of measurement that we'll use fairly frequently in like 2 or 3 labs. We'll measure like the circumference of a balloon in centimeters. Milli is 1/1000th. We do most of the time with what in terms of millis? Milliliters. We will not be able to do milligrams. You got me thinking it, so I just wrote it down here. We will not be able to do milligrams because a milligram is what fraction of a paperclip? 1,000th of a paperclip. If you think about how small that is, 1,000th of a paperclip, that's really small. I had a scale that measured milligrams for a while, but it kept on breaking because it was like so sensitive. If you blew on it, it would like get messed up. You had to like have it stable, it's like box, and just like press down, try to measure milligrams. And for anything that we're going to do, we're not going to worry about the milligram. That's a really small unit of measurement. My clock is totally crazy looking right now. It says it's 10:15. There are other metric measurements that we are not going to make you learn because they are crazy. Have a nice day.